All right, so this is 1.6 part 2, where we talked about surface area of a sphere. This one's the volume of a sphere. So over here I have a sphere drawn, fairly roughly. But if you think about this as a ball, a three-dimensional ball, that's what a sphere is, right? Three-dimensional circle. Really, it's all the points that are equidistant from another point. So if this is the center, every point that is a certain distance, we call that the radius, away from the center point in three-dimensional space, all of those points together make up the sphere. So it's like a three-dimensional ball. And the volume is all the space inside of this sphere. So if you think about a ball and all the air that you would need to put into a ball to completely fill it up, that's the volume. And so there's a formula for volume of a sphere, and that is 4/3, 4/3 times pi. And of course, pi shows up whenever we're dealing with a figure involving a circle, right? So if we're talking about a circle or a sphere or a cylinder or a cone, you'll see pi. That's a very special constant. And then times the radius. Also, the radius is in there too. That's pretty important. We're talking about circles and spheres and cones and cylinders. And then because we're talking about volume, the units, whatever units they are, they're going to be cubed when we're talking about volume, right? And so remember how we get a cubic unit is we take the length of the unit and we multiply by itself 3 times. So that's how you can remember what what exponent goes here. It's cubed. It's 3. Let me put that in red for you. Okay. So that's the formula for the volume of a sphere. And let's just say that this particular ball here, let's say it's a basketball. Oh, I do have a basketball here, and actually, I can't really reach it right now. But it looks like, I would say maybe, I don't know, 20 centimeters would maybe be the radius. Let's just make a guess, okay? So the radius for a basketball is about 20 centimeters, let's say. So if we wanted to find out exactly how much air needs to go in there, okay, or if we were able to fill it with Jello or whatever, which would be really weird, but the space that's inside of that ball, or think about it another way. Let's say we had a pool of water, okay? And it was perfectly calm and perfectly still, and we knew how much water we had in there. If we submerged this basketball in the water in the pool, then you know what? The exact space that this ball would take up would raise the water level exactly that much. Okay, so you think about the air that can go inside. You can also think about the space that it takes up. And we don't care about the thickness of the basketball wall right now. But anyway, so 4/3 pi r cubed. So let's do that. 4, and yes, you can do this as well. 4 times pi times r cubed all over 3. Students ask me about that too, and that's totally fine. You can do all this up top first, then divided by 3. So volume is 4. I'm going to do 4 times pi times 20 cubed divided by 3. Okay, so don't do this, guys. There's a couple of things I don't want you to do. Make sure that you do not say, hey, there's a 3 down here and a 3 up here. I'm just going to get rid of those. Please don't do that, okay? That's very, very bad, okay? That's going to give you the wrong answer. It is illegal. And in some countries, I'm sure that there are hefty fines for doing this. And in my math class, it's one of those countries. But anyways, don't do that. It's bad math. Also, let's see, what else can you do? Don't try and simplify this number and this number. I mean, 20 and 3 doesn't jump out at you. You can simplify that. But don't go, okay, I can simplify these two things. No, because this thing is actually cubed. So you got to take that into consideration. It's not just that number. All right. I don't know if I'm making sense there or not. But what you need to do is literally on your calculator, okay, get on your calculator, and you turn it on, okay, and what we do is we go 4 times pi times 20 to the power of 3. Okay, you might need to put brackets in there, but let's just see what that gets us. Oh, that's a lot. Does that look like too big? Do you think? Well, 20 times 20 times 20 is pretty big, right? Like 20 cubed itself is 8,000, right? So let's see, times 4 pi. Let's see, did I need my brackets? Nope, didn't need the brackets. Good. Okay, so that's a pretty big number. Now we're going to divide that by 3. Okay? So that's 33,000 cubic centimeters. 4/3 pi r cubed, eh? Okay, so 33,510. That's a lot, isn't it? It is a lot, and I think a basketball is probably closer to 15 centimeters. I just went and grabbed the basketball and measured it out, and it's probably closer to 15, so it's not quite 33,000. But if we, you know what, we calculate what an actual basketball would be here pretty quick. Let's try it again, see if we remember what to do. 4 times pi times 15 to the power of 3. Okay, and then divide that by 3, and we get about 14,000 cubic centimeters. Okay, so about 14,000 would be maybe an actual basketball. This would be a little bit bigger than that. But anyways, that's how you find the volume of a sphere, and it's pretty simple. And I do want to talk to you about one more thing here before we go. I think just one more. Yep, a hemisphere. Okay, you're going to see this in your textbook. You're going to see this in the class. A hemisphere. So hemi is half. Okay, a hemisphere. So half of a sphere, and it kind of looks like this. It's just like a ball that's been cut right in half, right through the middle. Now, if we're talking about surface area, all right, it's different than volume. Okay, so volume. Let's do volume first. Volume is literally half of the sphere that it's cut from. So if we have 1/2 of 4/3 pi r cubed, that simplifies to, what's 1/2 times 4/3? Well, this 2 and this 4 can actually cancel out to give you 2 and 1. So it's actually 2/3 pi r cubed. So we have 2/3 pi r cubed. So that's the volume for a hemisphere. I guess over here, 2/3 pi r cubed. That's the volume, which is pretty easy, so I won't spend too much time on that. Surface area, though. Surface area. This is a bit trickier. It's a bit trickier. You know, some students would say, well, I know, Mr. Maxwell, a whole sphere is 4 pi r squared. So guess what? We're just going to do 2 pi r squared. Well, you're kind of right. The 2 pi r squared would cover all of the outside area of the top of that sphere. Now, if it's cut in half, really, if you think about the bottom of this now, the bottom is another one of those circles. So what we actually have is we actually have these 2 circles plus the base now. So we have surface area for a hemisphere is actually 3 pi r squared. So once again, the 2 comes from the top part of what would be that sphere or that ball. That's half, exactly half of, we did in the last lesson up here. See, half of that, so 4 pi r squared, half of that is 2. But then you've got that pesky base now, right? Because you've actually, where am I going? You've actually cut that off, and so you've got the base in the bottom, so you have to add 3. So 1, 2, 3. 3 pi r squared. And while we're at it, this kind of looks like a little bit of a, I don't know, like a monkey face or something. So I'm just going to finish that off for you and let you dream about, you know, monkeys or something for the next little while. Okay? Monkey face. Okay, so that's volume of a sphere and also volume and surface area of a hemisphere. So that's 1.6. That's the second of 2 lessons I've got up here on YouTube for you. So I hope you learned a lot, and good luck with the assignment here. I think the assignment that I have given, this may not be this year's assignment, but here's the assignment from the textbook. That may be your assignment that you're working on today. All right. Have fun.